Good morning one and all. So today we will move on to the next unit, Introduction to Relational Model. So in this unit we basically focus on the inception of the relational model, the basic key features of the relational model, and we also see what are the different commands we use to design and create the database, right. So in this unit we will be seeing about. So let us move on to the next unit, Introduction to Relational Model. This unit majorly focuses on the inception of the relation model, the key features of the relation model, and we will be also focusing on SQL commands. So where we use to design and create the database, right. So now we will move on to the introductory part of the relational model. So this relational model is most commonly used. This is the most commonly used database nowadays, and relational model, this is one of the data model in the DBMS. So we already covered, we already know that in DBMS we have 4 data models: hierarchical model, network model, relational model, and object oriented model. So this relational model is very commonly used, and this is the easiest way of implementing a data model, right. So this relational model was proposed by E.F. Codd in 1970s. Around 1970s, E.F. Codd, Edgar F. Codd is a person who has pioneered the relational model. So he used, so in a journal he published a paper using relational algebra, using relational algebra. So where he proposed 12 Codd rules. He proposed 12 Codd rules. He proposed 12 Codd rules using the relational algebra. So using a simple mathematical functions, so he proposed all these rules. So where he told that the data could be very easy if you store the data in the form of tables, and if you store the data in form of tables, so it is very easy to retrieve the data also. So how to store, how to retrieve, what kind of rules that we need to employ when we are giving the data into the table. So all those rules were proposed by the person called as E.F. Codd, and very often, so this E.F. Codd is considered as a father of database management system, because he is a person who has laid the foundation stone for the relational model. So in this 12 Codd rules, all the rules, the 12 Codd rules, he proposed from 0 to 12 rules, ranging from 0 to 12 rules, to a total of 13 rules he has proposed using the relational algebra and tuple relational calculus. Using relational algebra and tuple relational calculus, he has divided 0 to 12 Codd rules, ranging from 0 to 12, a total of 13 Codd rules, which includes the information rule, view update rule. So the rules like logical independence and physical independence. So like this, in all his rules he told about how exactly the data can be stored in the relations, and when we store this data in the relations, he also told how to get the data back, how to retrieve the data back, and how to integrate, how to maintain the consistency between the data and integrity of the data, right. So Edgar F. Codd is a person who has pioneered this relational model. So in this relational model, we store the data in form of tables. So now we will see what is a table. So after this we will see what is a table. Fine. So now the data is stored in the form of tables, and RDBMS is used to manage the relational database. So what do we use here? So here, to manage all the to manage all the data in the relational database. In the relational database, we use RDBMS. What is this RDBMS? R stands for relation. R stand for relational. So, relational database management system is used to manage the relational database. What is this RDBMS? So, RDBMS is a collection of, it is a collection of organized set of tables, that are related to each other, right. So, what is RDBMS? So, RDBMS consists of a collection of organized tables, which is used to manage the data, right. So, we have seen the introductory part of the relational database. What is relational database? The data is stored in the form of tables. Now, we need to know what is this table is all about. What is a table, right. So, what is a table? So, that is the obvious answer we have to know, right. A table is nothing but a collection of rows and columns, right. What is a table? A table is nothing but collection of rows and columns, means a table will look like, so all these are rows, and a table is nothing but it also consists of columns, right. So, this is nothing but a table. How a table looks like? A table is nothing but a collection of, so what is this one? This is a row. Now, so generally in general English we call it as a row, and this one we call it as a column. But technically when we are moving to the relational database, so the terminologies of row and column will be changed. The terminologies will change. Now, the row is called as tuple. The row is called as tuple or record. The row is called as tuple or record, and for under the column we specify it as an attribute. Right. So, what is a table? A table is nothing but collection of rows and columns. So, technically speaking, a row is referred as a tuple or a record, and columns are generally referred to attributes. So, now we have to know some basic terminology in the table also, right. So, we have got this attribute. So, in the attribute, whatever the first row we have, always this first row occupies the attributes. Now, what is attribute? Attributes are nothing but the descriptional properties. The descriptional properties of an object that is considered to for the database design is nothing but an attribute. Yes, what is an attribute? An attribute is a descriptional property of the object that we have considered to design a database. So, whatever the properties that we are going to mention, so those properties has to be mentioned here. Those properties has to be mentioned in the first row of the table. And later, so what we need to mention? In the later rows or in the later tuples, you need to add values of the attribute. What you need to add? You need to add values to the attributes. So, what is this value? Suppose, for example, I just want to maintain a customer table. Right. So, what could be the probable attributes for the customer? So, I will take customer ID as one attribute. So, customer name, it is not mandatory. So, what are the products he purchased? So, I will take customer name also. Products purchased, okay, products. So, I will give products, quantity. So, whatever. I can also take address and phone number also, right. These are the different descriptional properties I have taken for the customer. Now, so what you need to give now? So, in the first row, what have we mentioned? We have mentioned the descriptional properties of a customer. Now, later in the next rows, you need to specify the values. So, means suppose I will give customer ID as 1, 2, 3, 4. Okay, we have customer 1, so whose name will be XXX. So, he has purchased a product, so of something quantity of 2. He has purchased a product ABC with a quantity of 2, and according to that we will put a price of that. Again we have one more customer whose name is YYY, and again so he has purchased one more product BCD with of a quantity 1. Likewise, always in the first row, so you need to carry the properties of the customer, you need to carry the properties of the customer, right, and later in the next rows you have to give the values of the descriptional properties what we have taken, right. So, we know what is a tuple is nothing but a row, means this entire thing will be a tuple, this entire thing will be a tuple, right. So, now we need to know about attribute domain. What we have to know? So, you need to know about attribute domain. So, as we know, domain is nothing but a range of values. Attribute domain is nothing but the possible set of values that we can be inserted in an attribute, right. So, what do you mean by attribute domain? The possible range of the values that we have to give for an attribute is nothing but attribute domain. So, say this, I will take phone number as an attribute, phone number as an attribute. So, what is the attribute domain here? So, this attribute domain, so phone number will not allow characters, phone number will not allow characters, and at the same time the phone number should carry 10 digits, the phone number should carry 10 digits. So, this is the normal domain of the phone number, or else we will move for one more example, age. Yes. So, when we have mentioned age as an attribute for a person, so what it could be here? So, this age can be in between 10 to 20, means the age column, the age attribute will accept only those values that falls in between 10 and 20, that falls in between 10 and 20, right. So, if at all I give a or minus 10 or any other value other than this 10 and 20, it won't accept, right. So, that is nothing but your attribute domain. What is attribute domain here? The set of possible range of values that we can insert for an attribute is nothing but an attribute domain. So, now, so again we have two more terms called as degree and cardinality, degree and cardinality. So, what is degree here? So, degree is nothing but the number of attributes that we have added for an entity, for a relation is nothing but degree, right. What is a degree? Degree is nothing but the number of attributes that we have given for a relation is nothing but a degree. And what is cardinality? So, cardinality is nothing but the number of tuples over here. The number of tuples we have for a relation is nothing but a cardinality. We will see a small example here. So, I will take student as an entity. For the student, I am going to create a table, right. So, this is a table. What is a table here? A table is nothing but a set of rows and columns. What you need to mention in the first row? You need to mention the attributes here. So, I will mention student ID, student name, student address and student age, and also I will mention student phone number. student phone number. So these are the attributes. So what are these? Are called as attributes of which entity? These are called as attributes of student entity. And what is the degree here? So I will give you all the examples 1, 2, 3, 4. So I will mention ABC. We have John, Teddy, Mark. So we have 4 students ABC, John, Teddy and Mark. So whose address is Delhi, Mumbai, Hyderabad and Vizag. So whose age is 21, 20, 22, again 21. So phone number, whatever the phone number. So we will take an example. Right. So this is a table I have mentioned here. So what is the degree here? What is the degree of this relation? So see here, so we should not call it as a table. We can call it as a table, but technically you need to call it as a relation. This is a relation, this is a student relation. This is a student relation which has got the degree. What is degree here? Degree is nothing but the number of attributes in a relation is nothing but a degree. So how many attributes do we have here? 1, 2, 3, 4 and 5. So simply degree of the relation, student relation is 5. And what is the cardinality here? So cardinality refers to the number of tuples over here. What are the tuples? Tuples are nothing but rows. So all these are tuples, right? So tuples or records. Tuples or records we can call it as. How many tuples do we have here? 1, 2, 3, 4. So what is the cardinality? 4. The cardinality of the student relation is 4. So means the number of attributes in a relation we specify it as a degree, and the number of rows in a relation we specify it as a cardinality. So then we need to know about the schema of the relation. We need to know about the schema of a relation. So this schema will tell you about the name of the relation, what are the different attributes in a relation, and what is a data type of the relation. So generally the schema is included within the greater than and less than symbol. Now what is a schema? What is a student schema here? What if first you need to mention the name of a relation. What is the name of the relation? Student. So this student has got, the student relation has got how many attributes? So whatever the attributes we are mentioning for a relation, so all those attributes you need to mention. So see here, ID, name, address, age and phone number, right? So these are the attributes for the relation student. Now apart from this, apart from the name of the relation and the attribute of a relation, you should also mention the data type of each and attribute. For each attribute, what is the type of data are we entering? So see here, so student ID, what is the type of data are we entering here? All these are numeric data, means we are having integer. This student relation is accepting integer data type for which attribute? For the first attribute ID, student ID. Then what is student name? What are the data? What type of data are we accepting here? Characters. Now means for the name attribute we are accepting character data, and even for the address also, so it is a multiple. So address can be, we can give the integer data and also the character data. So for the door number we specify in the number format. So here we have a special data type called as variable character. Variable character means both integers and characters can be included, right? So in this way the schema will carry, the schema includes name of the table, attributes of a table, and also the data type of each attribute specified in a relation. Yes. So, this is about the basic thing in the relational model. Okay. So, let me quickly summarize. What is a table? A table is nothing but collection of data elements which are organized in rows and columns, right. So, if you see the basic terminology